Okay, so good evening, everybody. Good evening, Gajendra. Good evening, Alan. Ayan, good evening. Ranjini, good evening. And today we are celebrating the Republic Day. So happy Republic Day to all of you. Mehra, good evening. So GATE exam is very near. It is going to be held at the 5th of February. And I think you might have completed all your syllabus. You might have completed the previous year question practice. You might have completed some other question practice. And to strengthen your knowledge, to strengthen your conceptual knowledge in the electrical machine, from today I am going to start a new session, and its name is the 51 most expected questions of the electrical machine. In this session, we will try to cover approximately 51 questions. It may be more than the 51 question in the 4 session. For each machine, I will take the one session for the transformer. Tomorrow we'll start the induction motor, then one session for the DC machine, and the one session for the synchronous machine. So one by one, we will complete the overall 4 machine through the conceptual question. So it will, Happy Republic Day, RK Charan. So it will give you a confidence before appearing into the GATE exam. Namaste Raju, how are you? Himanshu, Happy Republic Day. RK Charan, Happy Republic Day. So first of all, I would like to tell you the modus operandi of this session. In today's session, I will cover the 15 question of the transformer, and I will give you approximately 3 minutes to 4 minutes to solve this question. I think the 3 to 4 minutes will be the sufficient to you to solve this question, because in the GATE exam you at least you have to do the you have to solve the question between the 3 to 4 minute time. So first you will try by your own, then we will discuss these questions. So suppose if you fail to solve this question, do not need to be demotivated, because it may be the new concept for you. Some new concept maybe because I design this question myself. So we will try to learn the new concept so that before appearing to the GATE exam, you gain some more confidence. So let us start. Okay. So are you ready, guys? Now I will see who will be the champion of transformer. कौन बनेगा ट्रांसफार्मर का चैंपियन? So this is about me. I am Ajay Gupta. I am more than the 20-year experience, and I done my graduation from NIT Jaipur. I got the single digit rank both in EAC and the GATE exam, and I cracked the EAC exam both with electrical as well as electronics branch. I deal with the electrical, all the core subject of electrical branch and the control system and the network theory. So I think the 3 to 4 minutes will be sufficient to solve the question. So I'm going to start with the first one. Before starting the question, let me share this information. The nothing is impossible. This session will be done by the Rakesh sir and the Ankit sir. The time will be 11 a.m. from 29 January and the 30th January. It is the maths marathon session. So this is the first question. It is from the magnetic circuit, because in electrical machine we deal with the electrical circuit as well as magnetic circuit. So we must know how to solve the magnetic circuit. So in this, a circuit is given. The magnetic circuit shown in the figure has a coil of 500 turn. This is a coil which has a 500 number of turn wound on the central limb, which has a air gap of 1 mm. The magnetic path from A to B, this is the magnetic path, via each outer limb is 100 centimeter, and via the center limb is the 25 centimeter. Air gap length is excluded. The cross section area of the center limb is given and the outer limb is given. A current of 0.5 ampere is flowing in the coil. It produces the air gap flux of 0.35 milliweber. You have to find out the relative velocity of the medium. You have to find out the relative velocity of this core medium. So I will give you the 4-minute time to solve this question. So your time start now. This is the magnetic circuit. The coil is wounded on the central limb and the total number of turn of the coil is the 500 turn. The central limb has a air gap of 1 mm. The magnetic path from A to B. This is from A to B. The magnetic path from A to B. See, this is from A to B. It is the 100 centimeter and the length of central limb is the 25 centimeter. There is a air gap of 1 mm. The cross section area of central limb is given. The cross section area of the outer limb is given. The current flowing is the 0.5 ampere. It is producing the air gap flux of 0.35 milliweber. You have to find out the relative velocity of this core material. Manish, good evening. Ajay, good evening. Name is Manish, good evening. Varnakam Surya Prakash. I have not given any option for this question. It is a NET type of question. Tell me what is the relative velocity of this medium, the medium of the core. Mayank, good evening. Srasti, good evening. You can share the link of this class in your college and the GATE aspirant group so that the maximum student can get the benefit from this class. I gave you 4-minute time to solve this question. I think you must able to solve the question from 3 to 4 minutes. Yes, it is the first question. It is already mentioned this is the number 1. Yes, nobody, only 1 minute and 11 seconds remain. What are you doing guys? अभी तक कोई रिप्लाई नहीं मिला. What is the reason? Only few days remain for the GATE examination. Just draw the magnetic circuit and solve the magnetic circuit. Two eight eight six. GATE ने आंसर दिया था 2886, which is the wrong answer. Good evening, Sahu. Yes, only 3 seconds remain. Do you need more time? Yes. Ram Ram, Jai Sri Krishna, Akhilesh. Do you need more time to solve this question? Because not a single guy replied the correct answer. 74.2 is the wrong answer. Okay. 2636 is also wrong answer. Just draw the magnetic circuit. Good evening, Mayank. Draw the magnetic circuit and solve this magnetic circuit. See, between A to B, these are my two outer limb, A to B. The length of the core is 100 centimeter and its cross section area is given. The outer limb has the cross section area of the 2.5 centimeter into the 3 centimeter. So we can find out the reluctance of A to B, and similarly in this outer the A to B. The reluctance will be same. So what is the formula of the reluctance? Reluctance is L upon mu A. Mu naught mu R multiplied by A. This is the value of reluctance. So what is the value of length? Length is 100. Mu naught is 4 pi into 10 raised to the power minus 7. Mu R relative permittivity we have to find out. Area is given. The area of outer is 2.5 centimeter to 3 centimeter. So it is 2.5 into 3 centimeter. If I convert into meter, it is become 10 raised to the power minus 2 meter. Since area is given in the centimeter, so no need to convert into the meter. Oh, complete again. Reluctance. L is the 100 centimeter. Mu naught is 4 pi into 10 raised to the power minus 7. Mu r into 2.5 into 3 centimeter. Is it clear? Now, the reluctance of path AB, the reluctance of path AB, that is the middle leg. The length of middle leg is the 25 centimeter. It is a 25 centimeter. Mu naught is 4 pi into 10 raised to the power minus 7. Mu r, and the area of center limb is the 5 centimeter multiplied by 3 centimeter. 5 centimeter multiplied by 3 centimeter. Now flux is also passed through this air gap. The length of air gap is the 1 mm. Length of air gap is the 1 mm. So now I just find out the reluctance of air gap. It is 1 mm. So 1 into 10 raised to the power minus 2. 4 pi into 10 raised to the power minus 7. No need to use mu r here because it is the reluctance of air gap. Permeability will be the 4 pi into 10 raised to the power minus 7 only. And area is same, 5 into 3. 4 pi into 10 raised to the power minus 7. It is, I convert into the meter. So it is become, I convert all into meter. Clear? Now I am drawing the magnetic circuit. Suppose this will be my magnetic circuit. The reluctance of this, if you calculate, it will come 1060, sorry, 1061 into 10 raised to the power 9 divided by mu r. If I calculate this reluctance, it will come 0.133 divided by mu r into 10 raised to the power 9, and it's come 0.5305 into 10 raised to the power 6. This is reluctance 1 and reluctance 2. Reluctance 1, reluctance 2. Now it is the reluctance of air gap and reluctance of middle leg. Now this is the MMF. MF is the N multiplied by I. So here is a MMF, the source, N multiplied by I. Now the reluctance 1 and reluctance 2, they are connected in parallel. So this circuit is become like this. How to add the resistance? Reluctance. Reluctance is add like a resistance. It is RLAB, it is RLG, and it is N multiplied by I. So what is the MMF? MF is nothing but the flux multiplied by total reluctance. This is the flux. Flux is equivalent to a current in the electrical circuit. So MMF is equivalent to the flux multiplied by overall reluctance. So suppose N into I, it is equivalent to flux multiplied by equivalent reluctance. And total number of turn is equivalent to 500 and current is flowing is 0.5. So 500 into 0.5. Flux. Flux is given, it is creating the flux of 0.35 milliweber. 0.35 into 10 raised to the power minus 3. Now the total reluctance will be the sum of RL AB, the reluctance of air gap, plus the parallel combination of RL1 and RL2. If you put the value of these reluctance, RLAB is the 0.33 into 10 raised to the power 9 divided by mu r. RLG 0.5305 into 10 raised to the power 6, and RL1 RL2 both are equal, so the equivalent will be the half of this. Half of this is become 0. Actually it is 1.0, it was the 1.061, so it has become 0.531 into 10 raised to the power 9 into mu r. It is 250. From this formula, solve the value of mu r. You will get it is the 3612. 3612 is the correct answer. Clear? Mu r is 1 for the air gap, yes. The relative permeability of the air gap is equivalent to 1. So this is the questions from the magnetic circuit. Okay, now we move to the second question. A 20 kVA 2500 oblique 250 volt 50 hertz single phase transformer gave the following result during the open circuit test. The voltmeter reading is the 250 volt, ammeter reading is the 1.4 ampere, wattmeter reading is the 105 watt. It is a single phase transformer. If no load copper loss of the transformer is 5 watt and the ratio of hysteresis losses and the eddy current losses is 4 by 6, what will be the magnitude of hysteresis losses at 125 volt and 25 hertz? Four option is given: 20 watt, 21 watt, 425, 525 and none. Again I give the 4-minute time. It is a question from the open circuit test. The data of voltmeter, ammeter and the wattmeter reading is given. The no load copper loss is the 5 watt and the ratio of hysteresis losses and the eddy current losses is the 4 by 6. What will be the magnitude of hysteresis losses at 125 volt and the 25 hertz? Sum Goyal is saying it is a 20 watt. A 20 watt. Unacademy, sorry. Narsima is saying it is 20 watt. Manish says 120 watt. Any other answer except A? Still 2 minutes 38 seconds remain. Most of the student is saying that 20 watt is the correct answer. Yes, what about the others? Still 2 minutes remain. Best branch for placement is the VLSI, very large scale integration. Prince is saying that B is the correct answer. 21 watt is the correct answer. VLSI is actually the IIT give admission in VLSI for EC as well as for the electrical. Some IIT also give admission to the electrical student. Yes, you can opt. Electrical student can also opt. Okay, so only two options, A and B. Mostly student giving either the A option or the B options, 20 watt or the 21 watt. 21 watt and the 20 watt, which is the correct answer? Only last 20 seconds remain. Then go for the power electronics. Last 5 seconds. Okay. See, when we do the open circuit test, the open circuit test is mainly conducted on the low voltage side. If it is not mentioned in which side we are conducting the open circuit test, then you will imagine that we are going to conduct the open circuit test only on the low voltage side. That means the 250 volt side. So when we are doing the open circuit test, we apply the voltage. We are applying the rated voltage here because the 250 volt is the rated voltage of the low voltage side. And the 1.4 ampere current is flowing. 1.4 ampere will be the no load current because the secondary side of the transformer is a open circuited. We have not connected any load on the secondary side. So 1.4 ampere is the no load current and 105 watt is the reading of wattmeter. So what the wattmeter reading shows during the open circuit test? Basically, whatever the power we are taking from the supply, it will be given by the wattmeter. Basically, wattmeter is connected into the input side. So we are taking the power from the supply, and whatever power from the supply we are taking, it is given by the wattmeter reading. So see, the wattmeter reading, it is nothing but the input power from supply. Is it clear? And what is the input power? Whatever power we are taking from the supply, it would either available at the output or it would be converted into the losses. So input power is nothing but the output power plus losses. So what is the output power? Because my secondary side is open circuited, that means the current flowing into the secondary side is zero. So when current is zero, the output power will be the zero. So output power is the zero. So wattmeter reading is showing only the losses that is being taking place during the no load time. So what is the losses that is occurring during the open circuit time? It may be the copper loss because the current is flowing in the primary side. The current is not flowing in the secondary side. My secondary side is open circuited, but some amount of current is flowing in the primary side. The 1.4 ampere current is flowing in the primary side. So copper loss at no load because 1.4 ampere is the no load current. Generally, we imagine this, we neglect this copper losses because the magnitude of this copper loss is very less. But in this question, it is especially mentioned that the no load copper loss of the transformer is the 5 watt. So we have to take this copper loss at the no load time. Plus, there will be the core losses. The core loss depend upon the voltage. Since we are applying the rated voltage, so the core loss is occurring, it will be the rated core losses. So wattmeter reading will be the sum of two losses. One is the core losses and second is the copper loss at the no load. Some student might have neglected this copper loss at the no load because mostly time we neglect this copper losses. But in this question it is spatially given. So we have to consider this copper loss. So total reading is the 105 and the copper loss at the no load is the 5 watt. The copper loss is being taking place only on the primary side because the secondary side no current is flowing. So the overall core loss is become 100. So overall core loss is become 100. Clear? Now we have a two type of core losses, hysteresis losses and eddy current losses. So PH upon P, it is in the ratio of 4 by 6. So what will be the hysteresis losses? It is the 4 divided by 10. Out of 10, that 4 is the hysteresis losses, and the total loss is the 100. So pH is the 40 watt. So pH is the 40 watt. Now, in this question, they are asking about the magnitude of hysteresis losses when the voltage is 125 volt and frequency is the 25 hertz. When we conduct this open circuit test, then we applied the voltage 250 volt and the frequency was 25 hertz. So this is the hysteresis losses at 250 volt and 50 hertz. And we have to calculate this losses at 125 volt and the 25 hertz. So when we are varying the voltage and frequency, the ratio of V upon F is remains same, because the ratio of V upon M earlier was 250 divided by 50, and now we reduce voltage to the half and frequency to half. So when V upon F remain constant, then hysteresis loss is equivalent to A multiplied by F. It will only depend upon the frequency. So suppose at 50 hertz frequency, my hysteresis losses was the 40 watt. It is the 40 watt. Now, what would be the hysteresis losses if frequency is reduced to 25 hertz? If I divide equation number 2 by equation number 1, what will be the answer? The answer will be the 20 watt. हाँ, वो तो खैर अच्छी अलग बात है, हिंदी में पढ़ाएं तो ज़्यादा अच्छा लगेगा, क्योंकि हमारी जो मेन लैंग्वेज है, मतलब नॉर्थ इंडियंस की, वो हिंदी है। तो देखिए, इट इज़ ए 20 वॉट, बट कुछ स्टूडेंट ने इसको 21 वॉट किया था, बिकॉज दे हैव नेग्लेक्टेड द कॉपर लॉसेज एट द नो लोड टाइम। और ये नेग्लेक्ट आपने क्यों किया? बिकॉज यू डो नॉट हैव, आप इसको रट लेते हो कि इन द ओपन सर्किट टेस्ट द वॉट मीटर रीडिंग विल गिव यू ओनली द कोर लॉसेज, बट बेसिकली इट इज nothing but the wattmeter reading is the input power from the supply. So if the copper loss is given, we have to consider this copper loss into account. Is it clear? Yes, your language may be Telugu, some. Okay, now we come to the third question. A 200 kVA 1100 oblique 400 volt delta star transformer, it is a three-phase transformer, gave the following test result of a short circuit test, not the shortcut, it is a short circuit test, which is conducted on the high voltage side. It is the 350 volt, 4 ampere, 2 kilowatt. What will be the copper losses per phase? We have to find out the copper loss per phase if load is the 3/4 of the full load, if 3/4 of the full load is connected to the transformer. I think the 3 minutes will be sufficient for this question. It is a three-phase transformer. Primary side of the transformer is connected in the delta and the secondary side is connected in the star. The voltmeter, ammeter and the wattmeter reading is given. It is a 350 volt, 4 ampere and the 2 kilowatt. You have to find out the copper loss per phase if load is connected is the 3/4 of the full load. 2 minutes remain. Three-phase transformer. High voltage side winding is connected in delta and low voltage side winding is connected in the star. B. Ayan Malik is saying that B is the correct option. Prince Sharma again B. Soam Goel is saying 258.2. I am fine. हाँ बिल्कुल सफिशिएंट है. जय श्री कृष्ण गौरव. Only 20 seconds left. Soam Dubey is saying B is the correct answer. Harish is saying less than 2000. Less than 2000 means none is the correct answer. Very good, Gajendra. Less than 2 kilowatt. So what is the correct answer? It is a delta star. That means three-phase transformer. Primary winding, high voltage side winding is connected in the delta, and secondary winding is connected in the star. So see, this is the primary winding which is connected in the delta. Secondary winding is connected in the star. Secondary side is the short circuited. Primary winding is in the star connected. So where you connect the voltmeter, wattmeter and ammeter in the three-phase transformer. The voltmeter is connected between any two line terminal. This is voltmeter, and ammeter is connected here, and wattmeter is connected. We connect either 2 watt meter or the 3 watt meter, because the three phase power can be measured either using the 2 watt meter or the 3 watt meter. So we can use either 2 watt meter or 3 watt meter. The reading that is given, it is the combination of, that is the sum of 2 watt meter or the 3 watt meter. That means that is the overall watt meter reading. Suppose I am using the 2 watt meter W1 and the watt meter W2. So here the reading given is the W1 plus W2 it is given. So ammeter reading is the 4 ampere. This reading is the 4 ampere. So what is this 4 ampere? It is a phase voltage or the line voltage, sorry, phase current or the line current. This 4 ampere is the phase current or the line current. It is a line current. So at the line current of 4 ampere, the losses is the 2 kilowatt. Clear? It is a 2 kilowatt. See, we have to find out the copper loss when the 3/4 of the full load is connected in the transformer. So first I will going to find out what is the value of full load. 200 kVA is the rating of transformer. Transformer is 200 kVA rating. 200 kVA, that means it is the input side kVA as well as the output side kVA. So what will be the full load line current? Of primary winding? What is the full load line current of the primary side? What is the three phase KVA? Three phase KVA is nothing but the root 3 VL multiplied by IL. This is the three phase KVA and it is equivalent to the 200 KVA. That means 200 into 1000. So what will be the line current? 200 into 1000 divide by root 3 into line voltage. This is my line voltage. In the three phase rating, always the voltage or current is given is always the line voltage and the line current. So it is the 1100. So you will get the 10.497. This is my full load or the rated current. Full load current and the rated current both are the same. It is a line current. Is it clear? So see, whenever you are doing the short circuit test, the reading of watt meter is the 2 kilowatt. So what the watt meter reading show in the short circuit test? It shows you the copper losses. The copper losses at the operating current. When the 4 ampere current is flowing in the transformer, then the copper loss that will take place will be the 4 kilowatt. So this 4 ampere is nothing but the line current. This 4 ampere is the line current. So at 2 ampere line current, the copper loss is equal to overall copper loss is the 2 kilowatt. That means the 2000 watt. Is it clear? Now we have to find out the copper loss when the 3/4 of the full load is connected. So what is the 3/4 of the full load? This is my full load. So 3/4 of the full load is when the current will be the 3/4 times of the full load current, 10.497, and this current will be 7.87. So we have to find out the copper loss when 7.87 ampere line current is flowing. The copper loss is proportional to the current square. It is not proportional to current, it is proportional to the current square. So the overall copper loss is become this. So 7.87, sorry, it was the 4 ampere, 2 ampere नहीं था, ये 4 ampere था ना. Divide by 4, स्क्वायर करिए into 2000. So it's come 7742.11 watt. Is it clear? बताइए, is it clear? So D was the correct options. The D was the correct options. आप बताइए कहां पर आप लोग मिस्टेक कर रहे थे? Why आप लोगों ने B ऑप्शंस को करेक्ट क्यों माना था? What was the reason? बताइए, what was the reason? That was a very basic mistake because you considered this 4 ampere current as a phase current. It was not the phase current, it was the line current because you always connect the ammeter between the line. So it was the line current, it was not the phase current. एक सेकेंड, कितना आ रहा है? 200 000 divide by root 3. Okay, it was actually 11,000. यहाँ पर गलत करे, it was 11,000 voltage. So it is the 10.497. Clear? It was 11,000 oblique 400 volt delta star transformer. Okay, now we move to the next question. In a short circuit test, when performed on the high voltage side of a 10 kVA 1000 oblique 400 volt single phase transformer gave the following data: 40 volt, 4 ampere, 50 watt. If low voltage side is delivering half of the rated load at 0.8 power factor lagging at the 400 volt, what will be the voltage applied at the high voltage side? In this question, you can ignore the voltage drop in the primary winding. So ignore the voltage drop in the primary winding. 3 minutes 30 seconds I am giving you. The short circuit test is performed on the high voltage side of a 10 kVA 1000 oblique 400 volt single phase transformer. It gave the following data: 40 volt, 4 ampere, 50 watt. If the low voltage side is delivering half of the rated load at 0.8 power factor lagging at the 400 volt, that means it is the terminal voltage, 400 volt is the terminal voltage, then what will be the voltage applied at the high voltage side? यानी आपको हाई वोल्टेज साइड में कितना वोल्टेज अप्लाई करना है कि लो वोल्टेज साइड की वाइंडिंग के टर्मिनल पर आपको 400 वोल्ट मिले 0.8 पावर फैक्टर लैग के ऊपर. The short circuit test is performed on the high voltage side, that is the 1000 volt side. One minute 47 seconds. At present, you can appear in the GATE exam and the EAC pre-exam. No other reputed vacancies there. Maybe some state government vacancy may exist. Finally, 52 seconds remain. A 1085.57. In this question, neglect the voltage drop in the primary side. C 1042.78. Ayan Malik is saying C is the correct answer. 1065. Mank is saying 1065 is the correct answer. Sanjit is saying D is the correct options. Yes. So only one student, I think the two student gave the correct answer. It was the C, 1042.78. See, from the short circuit test data, we can find out the value of equivalent resistance and the equivalent reactance, because if you have the short circuit test data, you can find out the equivalent resistance and the equivalent reactance. The short circuit data is performed on the high voltage side. So we can get the equivalent resistance referred to high voltage side or equivalent reactance referred to the high voltage side. So high voltage side is my primary winding and the low voltage side is my secondary winding. So at high voltage side, we can find out the value equivalent resistance. What is the equivalent resistance? It will be power wattmeter reading divided by current square 4 ampere. I square R is the power. So it is the 3.75 ohm. Equivalent impedance, voltage divided by current. We have a voltmeter reading divided by ammeter reading. It is the 10 ohm. So you can find out the value of equivalent reactance. It will be under root of equivalent impedance square minus equivalent resistance square. Under root of 10 square minus 3.75 square. We'll get the 9.27. That is at the high voltage side. High voltage means the primary side. Here it is given at the secondary side, that means the low voltage side, I am getting the voltage, terminal voltage is the funded volt at the 0.8 power factor lagging. So terminal voltage, the voltage at the load terminal is the funded volt at 0.8 power factor lagging. So you know the E2 minus V2, the overall voltage drop is equivalent to I2 Re2 cos theta 2 plus I2 Xe2 sin theta 2. This is the formula of overall drop in the voltage I2 Re2 cos theta 2 plus I2 Xe2 sin theta 2. 3.125, 50 divided by 16. Okay, it is a 3.125. So X will be 9.49. So it has become 9.5. Okay. This is the equivalent resistance referred to the primary side, but we have to find out the equivalent resistance referred to the secondary side. So I will refer these all resistance and reactance to the secondary side. So Re2 is become Re1. Re1 is the 3.125 referring into the secondary side. 400 divided by 1000 because impedance refer as per the turn ratio square. So it will become 400 divided by 1000 square into 3.125, 0.5. and the XE2 is become 9.5 into 400 divided by 1000 square. It is 1.52. So from these two data, we can find out the value of E2 minus V2. So E2 minus V2, I2 RE2 cos theta 2. But this 400 voltage we are getting at the low voltage side delivering half of the rated load. When the load is not the rated load, it is the half of the rated load. So what is the rated current? First find out the value of rated current. Or full load current at secondary side. The kVA is equivalent to 10 kVA. Voltage is the 400 volt. 10 kVA divided by 400 volt. So 25 ampere is the full load current. So half load is 25 divided by 2. That means the 12.5. So at this value of current, we are getting the V2 is equivalent to 400 volt. So now the I2 RE2 cos theta 2 plus I2 XE2 sin theta 2. I2 is the 12.5. RE2 0.5 cos theta 2. Cos theta is the 0.8 power factor lag. Cos theta is 0.8 and sin theta would become 0.6. I2 XE2 1.52 into 0.6. Calculate this overall drop. 12.5 into 0.5 into 0.8 plus 12.5 into 1.52 into 0.6. It has become 16.4. E2 minus V2. V2 is the 400 volt. So from this we can find out the value of E2. It has become 416.4. Clear? So we have to find out the value of V1, the voltage applied at the high voltage side. So V1 will be equivalent to E2 416.4 I transfer this to the primary side. Ratio is the 1000 oblique 400. Neglect the voltage drop in the primary side if it is not given. It is 1041. 1041. Is it clear? ये इसके आसपास वो मैंने थोड़ा मिस्टेक कर दिया था, उसके अकॉर्डिंग थोड़ा आंसर चेंज हो गया. That is the 1041 would be the correct options. Clear? Whatever equivalent resistance, equivalent reactance we are getting, it is on the high voltage side, that is the primary side. So first we have to refer into the secondary side. You will get the value of RE2 and XE2. From this equation, we can find out the value of E2, and from E2 you can get the value of V1. Okay, now we move to the next question. A 1100 oblique 400 volt 50 hertz transformer has copper loss, hysteresis losses and the eddy current losses of 2%, 1% and the 0.5% respectively. If this transformer is operated at the 22 kV and 100 hertz supply, then what will be the efficiency of transformer assuming current to be same in both the cases. I'm giving 4 minute time. Copper loss is the 2%, stasis loss is the 1%, and the eddy current losses is the 0.5%. If this transformer is operated at the 22 kV and 100 Hz supply, then what will be the efficiency of transformer? Two percent, 1%, and the 0.5% is the out of the total power that you are getting. The loss is the 2%, 1%, and the 0.5%. It is 11,000. Sorry, it is 11,000. 11 kV oblique 400 volt transformer. 11 kV oblique 400 volt transformer. Yes, 1 minute and 42 seconds remain. 11 kV oblique 400 volt 50 Hz transformer. The copper loss, stasis losses, and the eddy current losses is given. If this transformer is operated at 22 kV and 100 Hz supply, then what will be the efficiency of transformer? Assuming current is to be same in both the cases. A 95.92%, Manish Ayan is saying D 97.32%. Sanjit is saying A is the correct option. Mayank is saying 97.32%. Gate is saying 97.32. Yes, what is the correct options? Only 30 seconds remain now. Ajay is saying A is the correct option. Imaginary access is saying A is the correct options. 9 seconds remain. Your time is up. See, when you connect this transformer with the 11 kV and the 50 Hz supply, this is my primary winding. So I connect this transformer with the 11 kV and the 50 Hz supply. The copper losses is 2%, stasis losses is the 1%, and the eddy current losses is the 0.5%. So the copper loss output power is the P1 is the 2% or 0.02. The stasis losses of output power is the 1%. and the AD current losses of output power is the 0.5%. Is it clear? But instead of connecting it to the 11 kV and 50 Hz supply, if this transformer is operated the 22 kV and the 100 Hz supply, that means we increase the voltage and we increase the frequency by 2 times. So this is at 11 kV and 50 Hz. This is the data if transformer is operating at the 11 kV and the 50 Hz. Suppose at 22 kV and 25 Hz, sorry 100 Hz. So voltage और frequency दोनों को double कर दिया. That means the V upon F ratio is the constant here. V upon F ratio is the constant. Since current is same, in second case also the current is same, but voltage is double. So power will be double because current is same but voltage is double. So power is become double. Is it clear? That means the P2 power will be the 2 times of the P1 power. Now when V upon F is same, then the hysteresis loss is proportional to AF. It is equivalent to A multiplied by F. So suppose at the frequency of 50 Hz, if hysteresis loss is the PH1, A into 50, and at the frequency of 100 Hz, it is become PH2. So if we divide equation 2 by equation number 1, the PH2 will be the 2 times of PH1. Is it clear? Similarly, the AD current losses is B multiplied by F square if V upon F is a constant. So at the frequency of 50 Hz, suppose it is the P1, but at the frequency of 100 Hz, it is become P2. If I divide this equation by this equation, you will get the P2 is the 4 times of P1. But what about the copper loss? The copper loss will remain same because the current is same, the resistance is same, the copper loss will remain same. So losses become 2 times, eddy current losses become 4 times, but the copper loss is remain same. Now in term of percentage, the hysteresis losses as compared to the total power, PH2 is the 2 times of PH1 and P2 is also the 2 times of the P1. So it is the same PH1 upon P1 and PH1 upon P1 is nothing but the 2%. So it is the 2%. Similarly, P2 upon P2, total eddy current losses, P2 is the 4 times of P1 and P2 is the 2 times of P1. So it is become 2 into P1 upon P1 and P1 upon P1 is the 0.5%. So it is become 2 into 0.5. So it is again 1%. Now the copper loss, the PC2 is the same as the PC1, but P2 is become 2 times of P1. So it is the half of the PC1 upon P1. And the PC1 upon P1 was the 2%. So it is become 1%. Clear है? Copper loss 2%, 1%. It is again became 1%. Now what is the efficiency? Efficiency is the output power divided by input power. Input power is again the output power plus losses. If I divide numerator and denominator by the output power, it has become 1. 1 plus losses divided by power. And losses divided by output power is nothing but the Pu losses. So it has become Pu losses. So 1 upon 1 plus copper loss is 1%. It is 1%, it is the 2%. So 0.01 plus 0.01 plus 0.02 निकालिए कितना आ रहा है. सॉरी, हाँ यहाँ मैंने गलत कर दी. हिस्टेरिसिस लॉस इज द 1% ना, ये इट इज 1%. सॉरी, इट इज वाज द 1%. वन प्लस वन क्या आएगा? 1.03. 0.9708. 97.08%. एग्जैक्टली कोई भी करेक्ट नहीं है. 97.08. It is more near to this D option. Exactly, it is a 97.08%. Core loss is approximately proportional to voltage square because hysteresis loss is proportional to the BMX and eddy current loss is proportional to BM square. Since BM is proportional to V upon F, so it is become approximately proportional to voltage square. Clear? Okay. Is it clear? नेक्स्ट पे मूव करें. चलिए नेक्स्ट आइए, एनर्जी टाइप का क्वेश्चन आइए. द एफिशिएंसी ऑफ ए 20 kVA 2000/200 volt single phase transformer at the full load unity power factor is 98% and half load 0.8 power factor is 97.5%. What is the Pu of equivalent resistance? एक मिनट, क्या हुआ? कोर लॉस हिस्टेरिसिस लॉसेस एडी करंट लॉसेस, ये तो है. हिस्टेरिसिस लॉस इज द 1%, एडी करंट लॉस इज द 0.5%. 4% क्या आएगा? मैं समझा नहीं. व्हाट इज द 4%? If you're not changing the value of frequency, then it will change the 4%. If V upon F ratio is a constant, then the hysteresis loss is proportional to frequency and eddy current loss is proportional to frequency square. मनीष, वो तब है जब आपने F को कांस्टेंट माना हुआ है, बिकॉज BM स्क्वायर, V is only changing the frequency is constant, तब ये होगा. But here we are also changing the value of frequency. बताइए. 3 मिनट का टाइम दे रहा हूं इसमें. The efficiency of a 20 kVA 2000/200 volt single phase transformer at the full load unity power factor is 98% and the half load 0.8 power factor is 97.5%. What is the Pu value of equivalent resistance of transformer? Pu losses means the losses divided by output power, exactly the kVA. That is the Pu losses. Q quantity is the actual quantity divided by the base quantity. In case of base quantity, we use the rated kVA, rated volt ampere. Here you have to find out the Q value of equivalent resistance of transformer. One minute 60 seconds left. I am giving a hint. The Q value of equivalent resistance is the same as the Q full load copper loss. Gate is saying it is a 0.013. 0.01352. Transformer efficiency is the output power divided by the input power. 0.0101, 0.27016. You have to find out the Q value of equivalent resistance. The Q value of equivalent resistance is the same as the Q copper loss. Q full load copper loss. 0.0135. 0.0135. Okay, your time is up. See, basically what is the equivalent resistance? Equivalent resistance is nothing but the Pu full load copper loss. Full load copper loss. Is it clear? Now what is the formula to calculate the efficiency? The efficiency formula is the X into VA cos theta. Divide by X VA cos theta. Cos theta 2 means the load power factor plus core loss plus X square times of full load copper loss. PSC is the full load copper loss. X square times the full load copper loss because at the X load, X is the fraction of load. Is it clear? By using this formula, you can find out the efficiency of transformer at any load and at any power factor of load. If I divide numerator and denominator by VA, VA is my rated voltage. I am dividing this equation by VA. It has become X into cos theta 2. X into cos theta 2. If core loss is divided by the rated volt ampere, this means it has become Q core loss. Q core loss plus X square PSC, that is the full load copper loss, is divided by the rated volt ampere. It has become the Q full load copper loss. And we have to find out the Q full load copper loss because the Q full load copper loss is the same as the equivalent resistance. So it is given at the full load annuity power factor, the frequency efficiency is the 0.98. So efficiency is the 0.98 at the full load. Full load means X is equivalent to 1. X is 1. What is the power factor? Power factor is the unity power factor. Cos theta is 1. So it is 1 into 1. Pu core loss, PC, x square times of, suppose I am taking this as it is a Pu value, into PSC. X is again 1. So x square, it is become 1 square. So what is the value of PC plus PSC here? Find out the value of PC plus PSC. If I divide 1 by 0.98 minus 1, it is 0.0204. It is in the Pu value. Is it clear? Now at half load and 0.8 power factor load, it is the 97.5. So it is the 97.5. That means it is 0.975 at the half load. X is half and power factor is 0.8. So 1 by 2 into 0.8. Core loss, Pu core loss हो गया. X is the 1 by 2 square. It has become 1 by 4. 1 by 2 square half load PSC. So the PC plus PSC is become PSC by 4 is become, it is 0.4 divided by 0.975, 0.41 minus 0.4, 0.010256 Pu. Is it clear? So from this equation number 1 and equation number 2, find out the value of PSC. PSC is the full load copper loss in Pu value. बताइए क्या आएगा? I think it will come 0.2583 Pu. 0.0135 आ रहा है. कंफर्म करिए. Yes, 0.253 is the correct. 135, एक मिनट रुकिए. If I divide equation 1 by equation number 2, it is become minus 3 by 4 PSC. PC will be cancel out and 0.0204 minus 0.010256. Yes, 0.0135. Yes, 0.0135 is correct. So answer will be the 0.0135. क्लियर है? आपको जो फॉर्मूला अप्लाई करना है, इट इज द formula of efficiency as per the Pu value, because the Pu equivalent resistance is the same as the Pu full load copper losses. Okay, now come to the next question. In 200/400 volt 20 kVA 50 Hz 2 winding transformer is connected as an auto transformer to transform 600 volt into the 200 volt with the load of 20 kVA 0.8 power factor lag connected to the 200 volt terminal. Determine the value of I. You have to find out the value of I. 3 minutes will be sufficient. It's a very simple question. The load connected has the value of 20 kVA at the 0.8 power factor lag. See the direction of current. As per the reference direction of current, what will be the value of I? A 200 oblique 400 volt 20 kVA 50 Hz two winding transformer is connected as an auto transformer. It is transforming the 600 volt to the 200 volt with a load of 20 kVA and 0.8 power factor lag. B minus 66.6. Imaginary axis and the gate is giving answer as a B. Mani's name is Mani. They are also giving B as a correct answer. Asoka the Great. B. Abhijit, Ayan Malik. Everybody is giving correct answer. Still 40 seconds remain. Kailash Dwivedi is saying D. 33.33 is the correct option. Kailash has deleted his message. Vaidhyalaya is saying B is the correct option. See, 20 kVA is the connected load. That means the transformer is supplying the 20 kVA output power. So in transformer, input power is equivalent to the output power, meaning that input kVA is equivalent to output kVA. So load connected is the 20 kVA. That means the transformer is supplying the 20 kVA or the 1000 volt ampere power. So if I find out the current that is flowing through the load, I2 is the current that is flowing through the load. Voltage is the 200 volt and VA is the 20 kVA. So it is the 20,000 divided by 200. So it is become 100 ampere. The current flowing in the load is the 20 ampere. Now the current that is drawing from the supply I1, input volt ampere is also 20 kVA. That means the 20,000 and voltage is the 600 volt. It will come 33.33. So see, we have calculated the value of I1 and I2. If I apply the Kirchhoff current law here, the I1 current is ending at this node and I and I2 current is leaving from this node. So I1 is equivalent to I plus I2. So I1 is equivalent to I plus I2. Just I am applying the Kirchhoff current law. I plus I2. I1 is the 33.33. I we have to find out. I2 is the 100 ampere. So I is become minus 66.67. Minus means the current is flowing opposite to the reference direction of current. Is it clear? So the B is the correct option. Mostly सब स्टूडेंट ने करेक्ट किया था ये वाला क्वेश्चन. चलिए now we move to the next question. Three two winding transformer has the following leakage impedance. Three transformer is given 200 kVA, 100 kVA and 50 kVA. If not is, if no transformer is to be overloaded, calculate the greatest kVA load that can be supplied by the three transformer in a parallel without overloading a single transformer. How much the load can be supplied by the overall parallel transformer? Again giving the 3-minute time. The PU leakage impedance is given of transformer 1, transformer 2 and transformer 3. You want the PD of this class? I can give the PD of this question. I don't know how to. Okay, I will give you the PD of this class. You just message me at my WhatsApp number. I will upload the PD of this class at my Telegram channel. Is it clear? अब बताइए। अब आ रहा है साउंड? ओके। चलिए। That means the transformer A, which has the lowest leakage impedance, will be overloaded. So we all know the power supplied or the load setting by the transformer is inversely proportional to their leakage impedance. So it is proportional to the ZE1 S1. Similarly, the load supplied by the transformer 2 will be the inversely proportional to its leakage impedance. Of RR. Wait. What happened? Wait, I'm sharing the screen. एक सेकेंड रुकिए, वेट करिए 2 मिनट। स्पीड नहीं आ रहा है, बीच में रुक गई क्लास। वो स्क्रीन नहीं आ रहा है बच्चों के पास, उधर पीछे बैकग्राउंड नहीं जा रहा है, ओबीएस वाला बीच में जाए। ठीक। वॉइस चेक करिएगा, वॉइस वॉइस वॉइस। वॉइस मिल रही है आपको? ओके। Okay, so load sharing by transformer 3, it is proportional to its leakage impedance. In this formula, either we have to use the actual value of leakage impedance or you convert all the leakage impedance into the same base. So I am converting all impedance into the same base. I am taking the base impedance 0.200 kV as a base impedance. kV as a base impedance. Because either you use the actual value of impedance or convert into the same base value, 200 value. So the leakage impedance of transformer will remain same. It is 0.03. But the leakage impedance of transformer 2 is become 0.4. I am converting this into the 200 kVA base. Its own base was the 100 kVA. So it is become 0.8. ZE3, it is 0.05. Again I am converting into the 200 MVA base. So it is become 0.2. Oh sorry, it was 0.04 pu था ये, यहाँ पर उन्होंने गलत लिख दिया. It was 0.04 pu. So it is become 0.04 pu. It was become 0.08 pu. Is it clear? Now the overall load impedance SL, it will be proportional to the summation of all equivalent impedance. So see, the transformer 1 has the lowest leakage impedance value in the PU value, so it will be overloaded first. So transformer 1 will be overloaded first. Overloaded first. So it will reach up to its rated value first. It will start supplying the power up to its rated value. Then it will start overloading. So see, if S1 upon SL is the 1 upon ZE1 divided by 1 upon summation of ZE. If transfer 1 is start supplying to its rated value, then we will get the maximum output power, because after this value the transformer 1 is become overloaded. The ZE1 is equivalent to 0.03 and summation of 1 upon ZE1 is the 1 upon 0.03, 1 upon 0.08, 1 upon 0.2. Okay. So if you solve this equation, we will get the value of 305 kVA. So all parallel transformer combinedly can give the power up to the 305 MVA, although its overall rating is equivalent to the 350 kVA, but these transformer cannot supply the 350 kVA. It can only supply up to the 305 MVA. If you start taking more than this value of power, then the transformer 1 will get overloaded. Is it clear? S1 maximum is the 200, sorry. Yeah, okay, this is 200. Then only you will get the 305 kVA. Okay. Now come to the next question. Two single phase transformer has the following data. Transformer A, the voltage ratio is given, leakage impedance is given. Transformer B, the voltage ratio is given, the leakage impedance is given. These two transformers are connected in parallel and 4000 volt, it is not the 400, it is a 4000 volt is applied to high voltage bus bar. Then find out the power loss due to the circulating current. You have to find out the power losses due to circulating current, because the turn ratio are not equal, so the circulating current will flow, and due to this circulating current the power loss will takes place. So what will be the overall power losses due to this circulating current? Again, I am giving the 3-minute time. The turn ratio of transformer A and the transformer B are not equal, so the circulating current would flow. You have to find out the copper losses or the additional power losses due to this circulating current. Yes, 1 minute 36 seconds remain. D is the correct option as per the gate. अभी तक सिर्फ गेट नहीं किया है, and as per the gate the D is the correct option. Ayan, as per Ayan, the D is correct option. Vaidhyalaya, D is the correct option. Imaginary axis, the B is the right option. 122.32. Okay, see, this is my single phase transformer. In single phase transformer, we have a incoming bus bar and the outgoing bus bar, and between these two bus bar the two transformer is connected in parallel, transformer A and transformer B. Their primary side is connected to the primary bus bar and secondary is connected with the secondary bus bar. Is it clear? Although their turn ratio or voltage rating is equal to 6000/2300, but we are applying only 4000 volt in the high voltage side. Here we are applying only 4000 volt. In the primary winding of both the transformer. Then the induced EMF in the secondary transformer is equivalent to E2A and the E2B. So what is the value of E2A? As per the turn ratio, the EMF will be induced. So turn ratio is the 230/6000. 230/6000, and we are applying the 4000 input voltage. So this E2A will come 153.33. Similarly, the induced EMF in secondary side in B transformer ratio is the 200/6000. 200/6000 into 4000. 4000 is the primary voltage. So here the induced EMF is the 133.33. So in the secondary side, the EMF induced is not same. See, if I draw the equivalent circuit of both transformer, induced EMF in A type transformer is the E1A. Its leakage impedance is the ZEA. Leakage impedance of B type transformer is the ZEB. Its induced EMF is the E2B. If E1 and E2B are not equal, then the current will start flowing. The current will flow from E2A to E2B. Sorry, it is the E2A and it is E2B. Current always flow from high voltage to the low voltage. It is called the circulating current. So first I will find out the value of circulating current. What is the circulating current? E2A minus E2B, because the potential difference in this circular path is the E2A minus E2B, divided by total impedance. The total impedance is the ZEA plus ZEB. So E2A minus E2B, it is become 153.33 minus 133.33. ZEA plus ZEB, it is become 0.27. If I add all this 0.27, it has become 0.9. If you calculate, the magnitudes come 21.30. We are not bothering about the phase angle. Magnitude is the 21.30. So 21.30 current is flowing in this circular path. So what will be the copper losses? So the copper losses will be circulating current square. Copper losses occurred only due to the resistance. So resistance of A transformer and the resistance of B transformer. So 21.30 square, resistance of A transformer, it is the 0.12 and B transformer is the 0.15. 0.12 plus 0.15. So if you calculate, it will come 124.49 watt. This is the extra power losses that takes place due to the circulating value of current. Is it clear? Now in primary winding also the current will flow. Why? Because if the current is flowing in the secondary side of the wind transformer, then the circulating current also start flowing in the primary side of the winding. Because the transformer is a device in which you cannot change the current only in a single winding. If you change the current in the one winding, the other winding current will automatically be changed. Okay, come to the next question. A 11,000/415 volt delta star transformer feed power to a 20 kilowatt 415 volt 3-phase induction motor. The induction motor having the efficiency of 85% and the full load power factor of induction motor is the 0.85 lag. The high voltage side line current of the transformer will be. It is a question from the 3-phase transformer. 3-phase transformer is supplying to a 3-phase induction motor. I am giving the 3-minute time. It is both are at the same point, but the current is flowing due to the transformer action, because the transformer action is taking place between the primary winding and the secondary winding. So I1 upon I2 is equivalent to the N2 upon N1. So always remember, the circulating current flow both in primary as well as in the secondary winding. (11,000/415 volt star delta transformer. It is feeding power to a 20 kilowatt 415 volt 3-phase induction motor. The induction motor having the efficiency of 85% and the full load power factor of induction motor is the 0.85 lag. Then the high voltage side line current would be. (1.4592) as per the imaginary axis gate and cover. 1.452 is the correct option. Finally 50 seconds remain. We have to find out the high voltage side, that means the primary side line current of the transformer. Primary side is connected in the star. Last 10 seconds remain. Everybody is saying that B is the correct option. Okay. So it is my star delta transformer. Primary side is connected in the star. And secondary side is connected in delta. It is supplying power to a 3-phase induction motor. This is my load. It is called the 3-phase induction motor. It is supplying power to a 20 kilowatt 415 volt 3-phase induction motor. What is the 20 kilowatt of the induction motor? What is the rating of induction motor? It is the output power or the input power? In case of motor, the rating of motor is always the output power. So output of induction motor. Only in case of transformer, the output kV and the input kV are the same. For all other motor, the power is always the mechanical output power. It is the 20 kilowatt, that is the mechanical output power. Now the efficiency is given. Efficiency is the 85%. So what will be the input power? If I know the output power and the efficiency, I can find out the value of input power. It is 0.85 20,000 divided by input power. So it is become 20,000 divided by 0.85. This is my input power. So basically this is the input power. It is drawing this much amount of power. And the voltage is the 415 volt. 415 volt is always the line voltage. In the 3-phase device, whatever the voltage is given, it will always be the line voltage. So how much line current it is drawing? If I know the value of power, value of voltage, you can find out the value of line current. In case of power, power will be the √3 times of line voltage, line current multiplied by cos theta. So power is 20,000 divided by 0.85. Line voltage is given. It is the 415 volt. Line current we have to find out. Cos theta is given. Induction motor is working at the 0.85 lag power factor. So from this we can find out the value of line current. It is the 38.51 ampere. It is my value of line current. It is clear. So 38.51 ampere. So what is the value of phase current? So the phase current in the secondary side, it will be the 38.51 divided by √3. Okay. Now what will be the phase current on the primary side? The primary side phase current and the secondary side phase current. It is inversely proportional to the turn ratio. Turn ratio of the secondary side and the turn ratio of primary side. Secondary side turn ratio, it will be as per the voltage 450, and primary side turn ratio 11,000 volt is the line voltage, so it is become 11,000 divided by √3. So find out the value of IPH1. If you find out the value of IPH1, it will come 1.452. In case of star, the phase current and the line current is the same. So the line current will also be the 1.452 ampere. Is it clear? Okay, now we move to the next question. A 20 kVA 200/100 volt single phase transformer has the following parameter. R1 is given, R2 is given, L1 leakage impedance is given, leakage inductance is given, and M is the mutual inductance is given. If the primary side is energized from the 200 volt, 50 hertz supply. If secondary side a load of 3.J4 is connected, then find out the secondary terminal voltage. You have to find out the voltage across the load terminal. Neglect the voltage drop in the primary winding. Just neglect the voltage drop in the primary side. Fifteen question. We'll complete it till 7:30. Every day we will try to cover the 13 to 15 question. Up to Monday, because the Saturday, Sunday there will be no class, and from Tuesday we will start the power system. Power system we will also cover in the 4 days. Yes, the leakage inductance of primary and secondary side is given. Actually, change is the law of nature. You have to change time to time. 99.32 Abhijit. See, if I draw the equivalent circuit of transformer referring to the secondary side, referring to the secondary side, this is the equivalent resistance of transformer. Magnetizing inductance R2 X2, it would be the R1 dash, it will be the X1 dash, and this is the load impedance ZL. Load impedance is given, it is the 3 plus J4. 3 plus J4 is load impedance. R2 is given 0.20 is the R2. And what is the X2? x2 is nothing but omega into L2. Omega is 2 pi f into L2. So 2 pi f, L2 is given. L2 is the leakage inductance, that is the 40 Henry. 40 into 10 raised to the power minus 3. It will come 0.1256. So it is the 0.1256. We are applying the 100 volt here. So if I refer, this is my V1 dash, not V1, it is the V1 dash because I am transferring all parameter into the secondary side. So it is the V1 dash. In the primary voltage is the 200 volt, then the secondary voltage will be the 100 volt. So it would be the 100 volt. Is it clear? It would be the 100 volt. So neglect the voltage drop in the primary winding. We have to neglect the voltage drop in this winding. So 100 volt you will also get here, 100 volt. So no need to find out the value of R1 dash and X1 dash or LM because voltage here will also be the 100 volt. Is it clear? So if you know the voltage 100 volt, what is the voltage across this impedance? So voltage across this impedance will become 3 plus J4. Apply the voltage division rule. Sum of total voltage 3 plus 20, that means 3.2 plus J 4.1256. If you solve this, it will come 95.76. Even if it is given the core loss resistance, it does not have any meaning because when we are neglecting the voltage drop across R1 dash and X1 dash, the voltage across this terminal will be the same as the 100 volt. Clear? So no need to find out the value of R1 dash and the X1 dash. Okay, now move to the next question. It is from the transformer harmonic. 3 identical single phase transformer are connected in star on primary side. 3 single phase transformer are connecting as a transformer bank. The line to neutral voltage due to the fundamental component of flux is the phi1 is 200 volt. Due to the third harmonic flux and the fifth harmonic flux, the voltage is the 20% and the 4% of V1. It is a V1. The primary to secondary turn ratio of each transformer is the 1/4. What is the line to line voltage if secondary is also connected in the star? बताइए. Again I am giving the 3-minute time. Three single phase transformer is connected as a transformer bank. Flux is not sinusoidal, so the harmonic is present in the flux, and due to each flux the EMF is inducing. We have to find out the line to line voltage. Yes, 1 minute 30 seconds remain. सॉरी ये फ्लक्स ही था, इट इज द 5-1 ओनली ना, इट वाज 5-1, not V1, because we are comparing the flux. The 5-3 is the 20% of the 5-1 and the 5-5 is the 4% of the 5-1. Nobody. A 1413.01. Ayan is saying C is the correct option. Abhijit is saying A is the correct option. Imagery Access is saying A is the right option. Still 20 seconds left. As per the core, A is the right option. Okay, see 5-3 is 20% of the 5-1. That means it is the 0.2 times of 5-1. And 5-5 is 4% of 5-1. It is the 0.04 times of 5-1. Clear? The induced EMF, we are talking about induced EMF. The fundamental component due to the 5-1, the induced EMF is the 200 volts. So induced EMF in the primary side. Due to fundamental component of the flux. If I neglect the voltage drop, then the V1 is equivalent to E1. It is equivalent to under root 2 or 4.44 pi f n into phi. Fundamental flux is the phi1, frequency is the f. It is only f. Okay. Now the induced EMF in the primary due to third harmonic component due to phi3 flux. It is E3. E3 is the induced EMF in the primary winding due to third harmonic flux. It is become under root 2 pi. Third harmonic flux frequency is the 3f n into phi3. So it is become root 2 pi fn. The phi3 is nothing but the 0.2 times of phi1. So it is become 0.2 times of the phi1 multiplied by 3. So it is become 0.6 times of V1. Under root 2 pi f n into phi1. See हो जाएगा 0.6. This is the 200. V1 is the 200 into 200. It is become 120 volt. Okay. Now the induced EMF in primary winding due to fifth harmonic flux. It is E5. It is become under root 2 pi f. In place of f there will be the 5f n into 5. And the 5 is the 0.04 of 0.04 times of phi1. So 5 into 4, इट इज द 0.2 टाइम्स ऑफ V1 हो जाएगा ये. So it is become 40. Okay. Now at the secondary side, because we have to find out the secondary side is connected in the star, and we have to find out the secondary side line to line voltage. So see, secondary side is connected in the star, and in each phase the fundamental EMF is inducing. Suppose it is become E1 dash, I am taking it as a dash. Third harmonic EMF is inducing E3 dash, and the fifth harmonic EMF is also inducing. But we all know that the line voltage is always free from the third harmonic component. So this is my phase voltage, and the line voltage is the root 3 times of the phase voltage. Phase voltage means it is the E1 dash square plus E3 dash square plus E5 dash square. Is it clear? This is the phase voltage. But the third harmonic component does not exist in case of line voltage if it is connected in the star or delta. So overall line voltage will be only root 3 times of E1 dash square plus E3 dash square. Okay. So E1 dash, the ratio is 1 by 4. So secondary voltage will be the 4 times of the primary voltage. So E1 dash will be 4 times of E1, and E3 dash will be 4 times of E3. E1 was 200, 4 into 200, it has become 800. Sorry, E3 तो लेना ही नहीं, E5 लेना है. This is the E5. It is the 4 into 40, 160. So it is become root 3 times of 800 square plus 160 square. कितना आ जाएगा? If you find out, it is a 1413.04 volt. इसमें आपको क्या याद रखना है कि if the secondary side or prime is connected in the star or delta, the line voltage does not have the third harmonic component. And in case of third harmonic induced EMF, the frequencies become 3 times. And in case of fifth harmonic induced EMF, the frequencies become 5 times. Clear? Okay, now we move to the 13th number of question. The voltage applied on a unloaded single phase transformer is this much, and the no load current is this much. What is the core loss if primary winding resistance is neglected? That means my supply is not the pure sinusoidal. The supply also has the third harmonic component. So the third harmonic current is also flowing. If the primary winding resistance is neglected, what will be the core losses? B 69.82. The supply voltage is given and the no load current is given. The transformer is working on no load condition. It is a unloaded transformer. That means no load is connected on transformer. As per the gate and imaginary axis, B is the right options. After this question, we have 2 more questions to solve. As per the gate imagery axis in the ion, B is the right option. अभिजीत के अकॉर्डिंग भी बी राइट ऑप्शन है. Okay. This is a single phase transformer. That means we have a primary winding and the secondary winding. Unloaded transformer means no load is connected on the secondary side. So the current that is flowing in the secondary side is equivalent to 0. But the current is flowing in the primary side, and that will be the no load current only because load is not connected here. And we have applied voltage here. This is the V1. So V is given and current is given. It is the no load current I0. The resistance is neglected. So what is the power that we are drawing? The power input from supply. If you are giving the power to a transformer, it will either available at the output or it would be converted into the losses. Since no load is connected here, so the output power is equivalent to 0. So whatever power you are giving to the transformer, it is converting into the losses. So we have a two type losses. One is called the core losses and second is called the copper loss. It is giving no doubt, no current is flowing in the secondary side. So the secondary side copper loss is equivalent to 0. But suppose primary winding resistance is neglected. That means the primary winding resistance is equivalent to 0, approximately 0. So the copper loss on the primary side is also equivalent to 0. So whatever power we are taking from the supply, it is equivalent to the core loss only. And we have to find out the core loss. So to find out the value of core loss, we have to calculate the power input from the supply. If the voltage and current is given, we can find out the power. See, we have to find out only active power because only active power is convert from one form to the another form. All other form, reactive power does not convert from one form to the another form. So the power which is converting into the form of heating, that means the losses, it will be only active power. So we know only same frequency component make the active power. That means the omega frequency, fundamental voltage will create the active power with only the fundamental value of current, and the third harmonic voltage will make the active power with the third harmonic value of current. So what is the active power? Vrms Irms into cos theta. This is for the fundamental component. Similarly, Vrms Irms into cos theta. This will be for the third harmonic component. So Vrms is nothing but the maximum voltage divided by root 2. It is the 400 divided by root 2. What is the Irms? Maximum value divided by root 2. 0.43 divided by root 2. And cos theta, phase difference between the fundamental voltage and the fundamental current, it is the cos 40 degree. For third harmonic component, Vrms, again it is maximum value divided by root 2. Irms is the maximum value divided by root 2. And the phase difference between the third harmonic voltage and current, it is become 10. If you calculate this, it will come 69.82. Actually, it is a mixed question of network, measurement and the machine. You have to apply the concept of electrical machine, the concept of measurement, that only same frequency component make the active power, and the concept of network theory. Okay, now we come to the second last question. A three-phase delta star transformer has its delta side as a open circuited. The voltage placed between A and B point read 260 volt, and when it is placed between A to D point, it reads 300 volt. What will be the reading of voltmeter if it is placed between B and D point? The odd harmonic up to 7 harmonic is only considered, because the even harmonic does not exist, and you have to consider odd harmonic only up to the 7th harmonic. That means we have to consider fundamental frequency, 3rd harmonic, 5th harmonic and the 7th harmonic. दिख नहीं रहा? क्या नहीं दिख रहा है? Okay, I will give you 3-minute time. This is the secondary side. डेल्टा ओपन डेल्टा है, सिंपल. अच्छा, ये मेरे से नहीं दिख रहा है. I am drawing here. This is the secondary side. B point, A point and D point. A point, B point and D point. What will be the reading of voltmeter if it is placed between the point B and D? Between B and D. Between B to D point. Okay. I'm giving more time. Find out the value across B and D. This is the second last question. Only one question remains after this.
B 260 volt. Anybody? Except 260 volt. It is like this. Open delta. Suppose this is my A phase, this is B phase, and this is C phase. Or you can A, B, and C. So we have to consider harmonic up to the 7th harmonic. So in the E phase, EMF induced due to the fundamental component, EMF induced due to the 3rd harmonic component, EMF induced due to the 3rd harmonic component, EMF induced due to the 5th harmonic component, and EMF is induced due to the 7th harmonic component. Clear? Similarly, in the B phase, EMF induced due to fundamental, EMF induced due to 3rd harmonic, EMF is induced due to the 5th harmonic, and EMF is induced due to the 7th harmonic. No, all is the phasor. It is the phasor sum. In C phase also, EMF induced due to the fundamental, due to 3rd harmonic, due to 5th harmonic, and due to 7th harmonic. Is it clear? So if it says if the voltmeter is placed between A point and the B point, it reads the 260 volt. If you place a voltmeter between these 2 points, this is A point and this is B point. So what is the voltmeter reading here? It is the phase voltage across this A phase. Is it clear? So this under root of EA1 square, EA3 square, EA5 square plus EA7 square. This is the overall RMS value of the voltage across A and B point. It is equivalent to the 260. Is it clear? Now come to the and if the voltmeter is placed between A and D point, it reads the 300 volt. A and D point, this is the D point. Now what the voltmeter will read between A and D point? It is the voltage between these 2 points. So see, the fundamental, 5th harmonic and the 7th harmonic component, all 3 phase voltage has a phase difference of 120 degree. So it is the EA1, EB1 and EC1. What is the phasor sum of these 3 quantity? If we have a 3 equal phasor with a phase difference of 120 degree, the phasor sum of this will be equivalent to 0. So EA1 plus EB1 plus EC1, it is become 0. Similarly EA5, see, इन तीनों के क्रॉस वोल्टेज है ना, EA5, EC5 and EB5, this is also become 0. EA7, EC7 and EB7 is also become 0. So what remain? Only EA3, EB3 and EC3 remain, because EA3, EB3 and EC3, the 3rd harmonic is a co-phasal quantity. No phase difference exists between the 3rd harmonic component. So all sum is equivalent to the 3A3. Is it clear? It is equivalent to 300 volt. So ultimately EA3, it is the 100 volt. Okay. If you place a voltmeter between B and D point, if I place a voltmeter between B and D point, now what will be the reading of voltmeter? If you place voltmeter between B and D point, it will measure the voltage of these 2 arms, That means C phase voltage and the B phase voltage. Is it clear? Between these 2 points, it will measure the C phase voltage and the B phase voltage. So EB1 plus EC1. What is the phasor sum of EB1 and EC1? EB1 plus EC1. क्या हो जाता है ये? It is equivalent to EA1. Is it clear? Or it is basically minus EA1, because ultimately the EA1 plus EB1 plus EC1, it is equivalent to 0. So it is the minus EA1. Similarly, it is become minus EC5, and it is become minus EA5 and EA7. But if you add these two components, EB3 and EC3, so EB3 EC3, it is same as the EA3, so it has become 2A3. Is it clear? Because there is no phase difference exists between the third harmonic component, so you can add the EB3 and EC3, it is same as the EA3, it has become 2A3. So we have a fundamental component, we have a third harmonic component, we have a fifth harmonic component, and we have the seventh harmonic component. So overall this will become overall RMS value. Minus E1 square means E1 square. 2E3 square. EA5 square. And EA7 square. Is it clear? So it is become EA1 square plus EA3 square plus EA5 square plus EA7 square, and 1 EA3 I am writing here. So we know the value of this and we know the value of this. Just put the value here. EA1 EA3, it is the 260. अंडर रूट हटा होगा तो 260 स्क्वायर हो जाएगा, 260 स्क्वायर. EA3 was the 100 square. If you calculate, come 312.41 volt. क्लियर? टफ क्वेश्चन था, थोड़ा स्लाइटली टफ था. कितना आ रहा है ये? 3 into 100 square. No, 3A3 is the 100. EA3 is the 100. तो अगर मैंने इसको यहाँ पर लिया तो सेम आ गया ना, 260 स्क्वायर पर 100 स्क्वायर. क्लियर? Okay, now we come to the last question. A three-phase क्या बोल रहे हैं, 3 times of 100 into 2 करना पड़ेगा. किसका 100 times करना पड़ेगा? तो 278 आ रहा है क्या? सॉरी, यहाँ पर ये मैंने थोड़ा रॉन्ग कर दिया ना. यस 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 4 होगा ना, ये तो 4 यानी 3 होगा. यस, अब देखिए करेक्ट है ना, बिकॉज इज बेसिकली 4a3 स्क्वायर. सो यहाँ पर a1 3 ले लिया तो इट इज बिकम 3a3. ओके, so this is the last question of today class. A three-phase, three-winding transformer is connected in a star-star delta. The primary line to neutral voltage is this much. It has the fundamental component and the third harmonic component. If the phase turn ratio of primary to secondary is 1/3, then determine the voltage across the open delta of tertiary winding. The phase turn ratio of secondary to tertiary winding is a unity. Star star delta. Primary is connected in star, second is also star, third tertiary in the delta. And you have to find out the voltage across open delta. Yes, 1 minute 19 seconds remain. Only 30 seconds remain. The primary side voltage, it is given in between the line to neutral terminal. Last 20 seconds. A 169.70. So your time is up. Not working. ओके, चलिए स्टार स्टार एंड डेल्टा. प्राइमरी साइड कनेक्ट इन द स्टार, Secondary side is also connected in the star. But tertiary winding is connected in the delta. And we have to find out the voltage across open delta. That means between these two terminals I have to find out the voltage. So what is the voltage across this terminal? बताइए क्या होगा यहाँ पर? In earlier question I told you the voltage across these two terminals is equivalent to the only 3A3. It is the 3 times of the third harmonic component. It is the 3 times of third harmonic component. Because EA1, EB1, EC1 it is become 0. So we have to take only third harmonic component. 80 volt is the maximum voltage here. So what is the RMS value here? RMS value is the 80 divided by root 2. RMS value. It is given, it is the phase to line voltage. The turn ratio between primary to secondary is the 1 by 3. If it is 1 number of turn, it is a 3 number of turn. And the turn ratio between the secondary to tertiary is the unity. 3, that means it is the 3 also. 3 to 3. Unity and 1. So what is this voltage? 80. It will be the 80 multiplied by 3 into root 2. This is voltage. This is the third harmonic component. Third harmonic phase voltage. Okay, it will come 169.70. So the total voltage will be the 3 times of this voltage, 169.70. You will get 509.194. Clear? So this was our last question. So tell me which student has done all the question correct. कोई भी बच्चा है जिसने सबके सब क्वेश्चन को करेक्ट किया? You have done all the question correct. Seven. How many students did more than 10 question correct? Anybody? Yes, tomorrow we'll cover the induction motor, but tell me what should be the level of question? Should I maintain the same level of question or the question should be the more easy? सेम क्वेश्चन रखना है, ये थोड़ा लेवल थोड़ा कम का रखना है, इजी तरह के क्वेश्चन लेके चलना है थोड़े. It is a gate standard only. In the gate they ask the conceptual question. These all are the conceptual question. It hardly take only 2 to 3 minutes. Except few question, all question is up to the level of gate. थोड़ा और लेवल को रिड्यूस कर दूंगा इसको, ठीक है, अगर ये आपको ज़्यादा टफ लग रहा है. I will share this link into the Telegram group and my Telegram ID is Ajay Gupta _JPR. Okay, we'll keep the level up to the gate level. Because it is a new platform for me, so today I am feeling some problem regarding all these. So within 2 to 3 days I will be acquainted with this system. So we'll meet tomorrow at the same time, 5 p.m. We'll discuss about 13 to 15 question of induction motor. So after doing this type of question, you will get enough confidence. If you can do this question, you easily will able to do the question in the GATE exam. क्योंकि ये थोड़ा नया चीज़ है, थोड़ा मतलब मेरे को यूज टू नहीं, आई एम नॉट यूज टू दिस प्लेटफॉर्म, सो इट विल टेक सम टाइम. ओके, टिल दैट, गुड बाय एवरीवन.